So what we're going to have a look at today is triangles and the angles that are associated with triangles and what happens with them. So if I open up another program here, what I've got is a triangle here and I've got the angles marked, and we're going to move them around to create some different triangles there. So with this particular triangle, I've got this angle here now is 38 degrees, this one's 101 degrees, and this one's 41 degrees. If I add them up, 101 and 41 makes 142, and add 38 and I actually get 180 degrees there. What I can do is create a different triangle. So created a different triangle there. This one's now 70 degrees, this is 72 degrees, and this is 38 degrees. Well, 38 and 72 makes 110. And this extra 70 degrees there makes 180 degrees. So a different triangle, but again, the angles add up to 180 degrees. Well, I might take a different point here and start to move it around. And there we go, different triangle again. This angle here is now 56 degrees. This one's 63 degrees and 61. 61 and 63 makes 124. Plus the extra 6 is 130, and the 50 makes 180. So we can see that with whichever triangle we make, and we can make a whole heap of different ones, when I add up the three angles, then they will always add up to 180 degrees. And this triangle that we just finished off with, here we've got one that's 90 degrees here, so it's a right angle triangle, 52 degrees and 38 degrees. 38 and 52 makes 90, plus 90 is again 180 degrees. So we now can say that the angle sum of a triangle is 180 degrees from those different ones that we just created. So in any triangle, doesn't matter what type we have, when I take one angle and another angle and the third angle, and these are just symbols just to mark the angle, then those three angles, when I add them together, will always equal 180 degrees. There's some other facts that we need to know also, that our largest angle is always opposite the largest side. So here's our largest side, that will be our largest angle. Then our second largest angle is always opposite our second largest side. So there's our second largest side, there's our second largest angle. And also our smallest angle is opposite the smallest side. So smallest side, smallest angle. And you can see that's the smallest amount of turning there. So let's put a couple of these things together. Let's have a look at an isosceles triangle. Remember, an isosceles triangle has two equal sides. So because the angles opposite sides are according to the size of them, then there must be two equal angles if there's two equal sides. And they are opposite the equal sides, and they're called base angles. So let's have a look. An isosceles triangle there. There's our two equal sides. Now remember, I can actually take that triangle, isosceles triangle, and spin it around. It's still isosceles. Okay. And what we're saying is that angle that's opposite it and that angle opposite there, they must be equal because they're base angles. So there we go. They've got the same symbol in there because they must be the same. But what happens if it's an equilateral triangle? Because there's three sides equal in an equilateral triangle, which means there must be three angles equal. So here's an equilateral triangle. All three sides are the same. All three angles must be the same. And I've marked them with the same symbol. But we already know that when we add up the three angles in a triangle, they always add up to 180. So let's do it and see what happens. So the three angles add up to 180. Well, there's three of them there. But I don't want three of them, I just want to find the size of one of them. So if I divide both sides by 3, then I find that each angle is 60 degrees in an equilateral triangle. So, as we've just said, three angles in an equilateral triangle are all 60 degrees. So let's have a look at a few examples from what we've learned so far. Here's a triangle. I want to find the angle, and I know these two angles here, this one's 70 degrees and 50 degrees, and I want to give reasons why I'm going to find that angle. Well, I can add those three angles together and get 180 degrees. But why? Well, our reason is they're the angle sum of a triangle, because the angles in any triangle will always add up to 180 degrees. Now that we know that, let's simplify this part here. 50 and 70, well, that's 120. So theta plus 120 must be 180. That's going to make things a little bit easier now. To find theta, I'm going to subtract 120 from both sides, and I'll find that my missing angle there is 60 degrees. But you'll notice when it says giving reasons, where did I write my reason? I didn't write it here at the end. I wrote it when I used it up here at the beginning. So make sure when you're giving reasons, you give your reason when you use it. So I used it by adding up the angles equaling 180 because the angle sum of a triangle. So let's have a look at another example. Well, what type of triangle is this? Yes, it's isosceles because there's two sides the same, which means there must be two angles the same. Now remember, don't move that our orientation for our isosceles triangle can be in any direction. We just need to make sure that we recognize that, and if it's in a test or a textbook, you can turn that around so that it makes it easier for to read. So, isosceles triangles, there's our equal sides, so our equal angles must be the ones opposite them. So I can now say that this missing angle is 75 degrees. And why? Because the base angles of an isosceles triangle. I've said that they're equal here, so I don't have to say are equal in my reason there. So I can say that they're equal because they're the base angles of an isosceles triangle. So, a third example. Yes, another isosceles triangle. We know that that angle and this angle must be equal because they're opposite the equal sides. So I need to find that angle up there. But I did recognize that it's an isosceles triangle. So I can now put in there that angle is 65 degrees because they're meant to be the same. So what can I do with them? Well, now that I know two of the angles, I can help find the third one by adding them up, and they should add up to 180 degrees. But why? Because they're angle sum of an isosceles triangle there. There's my reason. I wrote it down next to where I used it. Simplify 65 and 65. That's 135. Something plus 135 is 180. Let's subtract 135 from both of those, and I find that the missing angle is 45 degrees. So let's go to a more involved question. Basically the same stuff, but it will look more complicated. Okay, here we've got P, Q, T, R, and S. Now this T is actually indicating that point there, not the angle, just that point. P is this point, Q is that point, R is that point, and S is that point. Now the question tells us that PQ, which is that line there, and RS are parallel. We want to find this missing angle, giving some reasons. So it looks a bit more complicated. But that parallel lines might be fairly useful. So let's have a look. I know that angle RQP, angle RQP, which is this angle here, is 40 degrees. Why? Well, this angle here is actually alternate with that one. It's between the parallel lines and on alternate sides of this line, which is my transversal. So this angle here is alternate with that one. And we know that alternate angles are equal when the lines are parallel. And I know that the parallel lines are PQ and RS. So let's put that in there. 40 degrees. Now what? Well, I know that these three angles in this triangle add up to 180 degrees. Why? Because it's the angle sum of a triangle, and I'm talking about triangle PQT, this one here. So I'm actually telling you what triangle that I'm using. So the angle sum of the triangle, and it's triangle PQT. Well, what's 40 plus 110? That's 150. So what plus 150 is 180? Well, let's just subtract 150 from 180, and it tells us that missing angle is 30 degrees. So using my reasons, writing them down when I use them, not down here at the end. So there's some examples to help you with working out different things with some triangles and their angles.